What if I told you that the voice you're hearing right now might not be human, that your next doctor, teacher, or even best friend could be a machine? It's no longer the distant stuff of science fiction. Artificial intelligence is already here, silently woven into your daily routines, and it's rewriting everything we thought we knew about thinking, working, and even feeling. From recommending your favorite song, to detecting diseases before symptoms show, to writing poetry that stirs the soul. AI is no longer just a tool, it's becoming a presence. But how did we get here? How did a concept born from myths, logic puzzles, and 1950s mainframes evolve into a force that's now shaping elections, driving cars, and generating billion-dollar economies? This documentary dives deep into the extraordinary journey of artificial intelligence, a journey that began not with code, but with curiosity. We'll travel back to ancient dreams of mechanical minds, trace the breakthroughs of 20th century pioneers, and explore the seismic shifts that brought AI into our homes, hospitals, and headlines. You'll meet the visionaries who dared to teach machines how to learn. You'll uncover the setbacks, the scandals, and the staggering progress. And you'll see how an idea once dismissed as fantasy is now defining the future of human civilization. Whether you see AI as salvation or threat, one thing is certain: its rise marks a turning point in history. This is the story of how imagination became innovation, of how algorithms grew into intelligence, and of how science fiction quietly became your reality. Welcome to the rise of AI, from sci-fi dreams to everyday reality. Long before silicon chips and neural networks, the dream of creating artificial minds stirred in the imaginations of philosophers, mystics, and mathematicians. The idea of non-human intelligence, of crafted thought, is not new. As early as ancient Greece, the myths spoke of Talos, a bronze giant built by the god Hephaestus to guard the island of Crete. In these legends, the line between man, machine, and magic was already blurring. A mechanical being, animated by divine force, patrolling the land, it was the earliest whisper of artificial life. Centuries later, in medieval Islamic scholarship, inventors like Al-Jazari designed intricate mechanical devices, programmable automata, water clocks, and humanoid robots that played music or poured drinks. These weren't just toys, they were marvels of engineering, driven by cams, gears, and flowing water. But beneath their mechanical grace was a philosophical question: could we make something that mimics life? Still, these were imitations of movement, not thought. The dream of true artificial intelligence demanded a deeper leap, not machines that act, but machines that think. That leap began with logic. In the 17th century, philosophers like René Descartes and Gottfried Wilhelm Leibniz believed that all human reasoning could be reduced to rules, a calculus of thought. Leibniz imagined a machine that could settle disputes through logic alone, a mechanical philosopher capable of thinking clearly and without bias. Fast forward to the 19th century, and a young British mathematician named Charles Babbage proposed something revolutionary: the analytical engine. With the help of visionary collaborator Ada Lovelace, who is now often celebrated as the first computer programmer, Babbage imagined a general-purpose machine that could perform any calculation, and in theory, follow logical instructions. Ada even mused that such a machine might one day compose music. Her words echo across time as the first hint of programmable creativity. But none of these ideas had the power to bring minds to life, not until a new force emerged in the 20th century: electricity. With electricity came the dawn of computing. In the 1930s, Alan Turing, a brilliant British mathematician, laid the foundation for everything AI would become. His concept of a universal machine, now known as the Turing machine, proved that a machine could, in theory, simulate any process of logic or mathematics. He didn't just ask how machines could think, he asked if they could, and how we would know if they did. Turing's provocative 1950 essay, Computing Machinery and Intelligence, posed the haunting question, can machines think? To answer it, he proposed the imitation game, what we now call the Turing test. If a machine could carry on a conversation indistinguishable from a human, did it matter whether it truly understood or just mimicked understanding? The seed was planted. Minds around the world were beginning to imagine intelligence as something that could be encoded, taught, even created. But in those early years, computers were still the size of rooms and spoke only in ones and zeros. Artificial intelligence, as a field, had yet to be born. Still the path was forming, paved by myth, guided by logic, and powered by the human hunger to recreate the mind itself. The stage was set. The dream was alive. And soon, it would find its name. The year was 1956. Inside a small lecture hall at Dartmouth College, a group of mathematicians, engineers, and logicians gathered for what would later be called the birth of a revolution. On paper, it was just a summer research project, but in spirit, it was the spark that ignited the field of artificial intelligence. The man behind it all was John McCarthy, a brilliant and ambitious computer scientist who coined the term artificial intelligence itself. Alongside legends like Marvin Minsky, Claude Shannon, and Alan Newell, McCarthy proposed something bold: that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. This idea wasn't about mimicking movement or calculating numbers. It was about teaching machines to reason, solve problems, and perhaps one day understand. The team believed that within a few decades, machines would rival the human mind. They were wrong about the timeline, but they were right about the potential. The first real breakthrough came not from solving grand philosophical questions, but from playing games. In 1951, long before the Dartmouth gathering, British scientist Christopher Strachey had programmed a computer to play checkers. Around the same time, Claude Shannon explored chess-playing algorithms. These games weren't just entertainment. They were contained, rule-based environments that allowed machines to make decisions, plan moves, and even learn from outcomes. But it was logic theorist, developed by Alan Newell and Herbert A. Simon in 1955, that truly marked a turning point. Designed to prove mathematical theorems from Principia Mathematica, the program was capable of completing logical proofs, and sometimes more elegantly than humans. Newell and Simon famously described it as the first artificial intelligence program. From there, excitement soared. Computers could now simulate a form of reasoning. Research labs across the United States, MIT, Stanford, Carnegie Mellon, began pouring energy into this new frontier. Then came ELIZA, created in 1966 by MIT's Joseph Weizenbaum. ELIZA mimicked a psychotherapist using scripted responses and pattern matching. Users were stunned. Some became emotionally attached. One man begged to speak with ELIZA in private, believing she truly understood him. But Weizenbaum, disturbed by how easily people projected humanity onto his machine, became one of the first AI ethicists, warning of the dangers of emotional deception. Still, ELIZA proved something profound. Conversation, the domain of poets, philosophers, and lovers, could be simulated by code. Technically, these early programs had limitations. They relied on symbolic logic, predefined rules, and narrow tasks. They couldn't understand the way humans do. They couldn't generalize. But each prototype pushed the boundary of what was possible. Then came the expert systems of the 1970s and 80s. One of the most famous was MySyn, a program designed at Stanford to diagnose bacterial infections and recommend antibiotics. It outperformed human doctors in narrow tasks, a stunning moment that signaled how AI might revolutionize medicine. But these systems faced a critical problem: scaling. As the complexity of decisions increased, so did the number of rules needed. AI researchers hit a wall, funding dried up, the dreams seemed to stall. This period came to be known as the AI winter, yet even in this cold spell, some were quietly rewriting the rules. Enter Geoffrey Hinton, a cognitive psychologist with a different idea. Instead of symbolic logic, what if we could mimic the way the brain actually works? Hinton championed neural networks, systems that learned by example, not instruction. Based on the architecture of biological neurons, these models weren't taught rules. They discovered patterns. They learned. In the 1980s, his ideas were ahead of their time. Computers weren't powerful enough. Data was scarce. Neural networks were dismissed. But Hinton didn't give up. By the late 1990s, hardware was improving, data was exploding, and the world was about to rediscover Hinton's forgotten flame. Meanwhile, in 1997, another milestone stunned the public. IBM's Deep Blue defeated world chess champion Garry Kasparov in a 6-game match. It wasn't true intelligence. Deep Blue relied on brute force calculations. But to the world, it was undeniable. A machine had conquered the most iconic symbol of human strategy. In truth, AI was still fragmented. Rule-based systems struggled with ambiguity. Neural networks lacked precision. Yet in the tension between symbolic reasoning and statistical learning, a new idea was forming. And soon, with the rise of the internet, massive data, and cheaper processing, that idea would catch fire. The prototypes were built. The foundations were laid. Now AI was ready to evolve, faster than anyone could imagine. Artificial intelligence didn't rise overnight. It climbed, one experiment, one breakthrough, one challenge at a time. From the hushed corners of research labs to the glowing screens in every home, the ascent of AI unfolded decade by decade, shaped by ambition, rivalry, and relentless innovation. Let us walk this timeline, not as passive observers, but as witnesses to the making of a technological era. After the landmark 1956 Dartmouth Conference, where John McCarthy coined the term artificial intelligence, optimism ran high. Early AI pioneers believed that human-level intelligence was only a couple of decades away. McCarthy, along with Marvin Minsky, Alan Newell, and Herbert Simon, spearheaded symbolic AI, building programs that could manipulate symbols and rules to solve problems. Newell and Simon's logic theorist proved theorems from Principia Mathematica. In 1958, McCarthy developed Lisp, the programming language that would dominate AI research for decades. Meanwhile, the U.S. Department of Defense and academic institutions funded AI research generously during the Cold War, hoping for machines that could translate languages, analyze surveillance data, or assist in warfare strategies. But symbolic AI was brittle. It worked well in constrained problems, like puzzles and games, but faltered when exposed to real-world ambiguity. By the 1970s, researchers shifted their hopes to expert systems, computer programs that replicated the decision-making skills of human specialists. These systems used if-then rules and a knowledge base drawn from experts. One notable creation was MySyn, developed at Stanford. It could diagnose blood infections and recommend antibiotics more reliably than general physicians. Another was Dendral, used for chemical analysis. These systems worked, but with limitations. They were hard to scale, and their knowledge had to be painstakingly inputted. Still, companies saw potential. By the late 70s, corporations began deploying expert systems for logistics, manufacturing, and customer support. It looked like AI had found its commercial niche. The early 1980s saw the AI boom. Corporations like DEC, IBM, and Xerox invested in expert systems. Japan launched its fifth-generation computer systems project, aiming to lead the global AI race. In 1985, over 250 companies were building AI-powered tools. Wall Street buzzed. AI was the future, or so it seemed. But cracks appeared. Expert systems were fragile. They couldn't learn from data. They broke when conditions changed. Maintaining them became a nightmare. Then the money vanished. Budgets were cut. Projects cancelled. The so-called AI winter set in, a period of disillusionment and retreat that spanned most of the late 80s and early 90s. But beneath the surface, another revolution was brewing. In the 1990s, the AI spotlight dimmed, but research didn't stop. The field evolved, from rule-based to data-driven. Statistical models gained popularity. Bayesian networks, decision trees, and support vector machines emerged. Instead of programming intelligence, researchers started training it. Meanwhile, three names kept the flame of neural networks alive: Geoffrey Hinton, Yann LeCun, and Yoshua Bengio. Their belief in connectionist approaches, the idea that machines could mimic the brain's structure, was not widely accepted at the time. In 1997, the world gasped when IBM's Deep Blue defeated world chess champion Garry Kasparov. It wasn't a learning machine. It relied on brute force search and predefined evaluation functions, but it demonstrated that computers could dominate humans in structured domains. Still, AI hadn't returned to the mainstream. The tools were evolving, but the dream remained distant. The new millennium brought a surge in data, and data changed everything. As the internet exploded, so did digital footprints. AI researchers now had access to the one thing symbolic systems had lacked: real-world information. Search engines like Google began leveraging machine learning to sort, rank, and personalize results. Algorithms became smarter, adapting based on user behavior. In academia, interest in neural networks resurfaced. In 2006, Geoffrey Hinton introduced deep belief networks, a new way of training multi-layered neural nets. AI was no longer about rules. It was becoming a discipline of probability, optimization, and learning from vast amounts of examples. Still, a catalytic breakthrough was yet to come. That breakthrough came in 2012. At the ImageNet competition, a global challenge in visual recognition, a deep neural network called AlexNet, built by Alex Krzyzewski under Hinton's supervision, blew the competition away. It halved the error rate, it used a GPU to train, and it proved that deep learning, once ignored, was the future. Suddenly, AI became hot again. Google, Facebook, Microsoft, Baidu, Amazon, tech giants raced to acquire AI startups and talent. Billions flowed into labs, research soared, applications exploded. AI could now recognize faces in photos, translate languages in real time, power personal assistants like Siri and Alexa recommend movies, products, and news, diagnose diseases from medical scans, drive autonomous cars. In 2016, AlphaGo, created by DeepMind, defeated Lee Sedol, a Go grandmaster. Unlike Deep Blue, AlphaGo learned to play. It used deep reinforcement learning, an AI learning, by playing millions of games with itself. It made moves no human would have thought of. The message was clear. Machines weren't just copying us, they were innovating. In 2017, the AI world shifted again. A paper titled "Attention is All You Need" introduced the transformer architecture. Unlike older models that processed language sequentially, transformers could analyze all parts of a sentence at once. They understood relationships, context, nuance. Transformers powered a new class of large language models, including Google's BERT, OpenAI's GPT-2, and later GPT-3. These models could write essays, answer questions, compose poetry, and simulate conversations indistinguishably from humans. AI was no longer narrow. It was starting to become general in function, if not yet in consciousness. By the 2020s, AI had woven itself into the world. Healthcare. AI scans images, predicts disease, accelerates drug discovery. During the COVID-19 pandemic, it modeled viral spread and supported overwhelmed hospitals. Finance. AI forecasts markets, detects fraud, manages portfolios. Law. AI analyzes contracts, predicts case outcomes, assists legal research. Retail. AI predicts demand, personalizes shopping, manages supply chains. Entertainment. Netflix, Spotify, TikTok, all AI-driven. Education, personalized learning, automated tutoring, plagiarism detection. AI also entered governments, powering facial recognition, surveillance, and public services. At the same time, the ethical conversation exploded. What about bias in algorithms, privacy erosion, job loss from automation, the danger of synthetic content and misinformation? Debates intensified. Some called for regulation, others warned of existential risks, but no one denied it anymore. AI had risen, and it was here to stay. There was no siren, no sudden announcement. The revolution didn't arrive all at once. It crept in, quietly, efficiently, and everywhere. In just a few short years, artificial intelligence went from a promising lab experiment to the invisible engine behind modern civilization. From smartphones to security cameras, online shopping to streaming platforms, AI made the leap from niche to necessity. And when it did, it changed more than just machines. It changed us. But what triggered the explosion? Three forces converged in the late 2010s: massive computing power, oceans of digital data, and refined learning algorithms. Together, they made AI cheaper, faster, and shockingly effective. Suddenly, AI was no longer just for PhDs and research centers. It was a product, a service, a solution. Tech giants led the charge. Google, rebranded as Alphabet, declared itself an AI-first company, embedding machine learning into Search, Gmail, and Google Assistant. Amazon used AI to drive personalized shopping, warehouse robotics, and the now ubiquitous Alexa. Apple brought Siri into every iPhone. Facebook, now Meta, applied AI to content moderation, ad targeting, and its newsfeed. AI wasn't a side project, it was the core operating system of modern tech. Meanwhile, in China, a parallel surge emerged. Companies like Baidu, Alibaba, and Tencent invested billions into AI. Government policy embraced automation, surveillance, facial recognition, predictive policing, all powered by AI, became central tools in urban management and national strategy. The arms race for algorithmic dominance had gone global, but the most profound change happened in silence, in the choices we no longer noticed. When you search for a question, it's AI that filters the answers. When you watch a movie, it's AI that predicted you'd like it. When you apply for a loan, when your resume is reviewed, when you unlock your phone, it's AI making the first decision. Entire industries began to restructure. In healthcare, AI detected tumors from scans with superhuman accuracy. It triaged emergency room cases. It predicted hospital overcrowding and even assisted in surgery. In finance, AI took over fraud detection, credit scoring, and high-frequency trading, making decisions in milliseconds, shifting billions. In transportation, AI controlled self-driving vehicles, optimized delivery routes, and powered navigation apps used by billions. In media, AI wrote headlines, filtered spam, edited photos and translated languages in real time. AI also began to reshape the workforce. Some jobs vanished, others transformed. New roles emerged: data labelers, prompt engineers, algorithm auditors. From warehouses to classrooms, AI became a silent colleague, or in some cases, a quiet competitor. Society too began to adapt, and not always with ease. Concerns over privacy, bias, and surveillance capitalism reached a fever pitch. Investigations revealed how algorithms reinforced discrimination. Debates raged over how much power should rest in the hands of companies whose models couldn't be fully understood, even by their creators. And yet, for most people, AI wasn't something to fear. It was something to depend on. When COVID-19 swept the globe, AI helped track outbreaks, analyze lungs, identify vaccine candidates, and manage logistics. In a time of crisis, it proved indispensable. By the early 2020s, it was clear AI had moved beyond research. It had become infrastructure, as essential as electricity, as invisible as air. This was no longer the age of experimentation, it was the age of AI. In the 2020s, artificial intelligence entered a new phase, not one defined by raw potential or headline-making breakthroughs, but by quiet dominance and refined integration. AI was no longer a singular innovation. It had become a constellation of technologies, each branching into industries, disciplines, and daily habits. It diversified, specialized, and evolved faster than any regulation could catch up. We didn't just use AI, we lived inside it. One of the clearest signs of this shift was the rise of generative AI. With models like OpenAI's GPT-3, Google's LaMDA, and Meta's Llama, language processing reached levels of fluidity once reserved for science fiction. These tools didn't just parse language, they generated it. They could write emails, compose poetry, summarize legal documents, and explain quantum physics in plain English. The public marveled, schools debated, workflows changed. Soon after, generative models spread to images, video, audio, and code. Tools like DALL-E, Midjourney, and Stable Diffusion created artwork from text prompts. Descript and 11 Labs synthesized. Realistic voiceovers. GitHub Copilot, powered by OpenAI, began assisting developers in writing software. The creative process itself became a collaboration between human intuition and machine suggestion. Meanwhile, AI diversified across industries in unexpected ways. In agriculture, drones powered by AI scanned fields to detect crop disease before it became visible to the naked eye. Smart irrigation systems used predictive algorithms to conserve water and boost yield. In energy, AI optimized grid distribution, forecasted demand, and even predicted wind and solar output down to the hour. In manufacturing, AI-driven robots didn't just perform tasks. They monitored quality, detected defects, and adapted in real time. Smart factories became testaments to the new industrial age. Even in space exploration, AI played a growing role. NASA used AI for spacecraft navigation, anomaly detection, and autonomous decision-making in remote missions. But this era wasn't just about expansion, it was about reckoning. As AI systems became more powerful, so did concerns around ethics, accountability, and social impact. Researchers pointed out the biases encoded into training data. Models trained on the internet absorbed not just knowledge, but prejudice, misinformation, and toxic language. And then there was the black box problem. Modern AI systems, especially large neural networks, often couldn't explain why they made a certain decision. This opacity created tension in sectors like healthcare and law, where explainability wasn't just preferred, it was essential. Governments began to respond. The European Union drafted the AI Act, aiming to classify AI systems based on risk and impose strict regulations. The United States published blueprints for AI Bill of Rights. China accelerated its own AI governance, focused on ethics and national control. At the same time, new research focused on responsible AI, fairness metrics, audit trails, privacy preserving, models and transparency tools. And the players changed too. While the early AI revolution was led by a handful of tech giants, the modern ecosystem is broader and more global. Startups in India, Nigeria, Brazil, and Eastern Europe began building domain-specific AI for local languages, healthcare access, rural education, and more. Open-source AI exploded. Projects like Hugging Face, OpenLLM, and LangChain made cutting-edge models available to everyone, democratizing access, but also complicating control. Even the term artificial intelligence started to evolve. People began talking about machine reasoning, augmented intelligence, and cognitive systems, reflecting a more nuanced view of what these technologies really did and how they worked alongside, not instead of humans. Today, AI is not a monolith. It is a living ecosystem, one that is refined, fragmented, and utterly central to the way we live, work, and imagine. It's difficult to measure the true legacy of a technology still unfolding in real time. And yet, when we pause to look back, the transformation AI has brought becomes undeniable. Before AI, the world was reactive. We responded to problems, chased patterns, and guessed at outcomes. With AI, we anticipate. We predict traffic before it forms. We spot disease before symptoms show. We hear customer complaints before they're spoken. The shift is not just in capability, but in mindset. A world built not on instinct alone, but on inference and intelligent design. Entire professions have changed. In healthcare, AI has permanently raised the bar for diagnostics and drug development. Doctors now work alongside algorithms, not in opposition, but in synergy, combining human empathy with machine precision. In transportation, predictive AI models coordinate global logistics and navigate driverless vehicles. In journalism, stories are curated, summarized, and even generated by machine. In entertainment, AI decides which songs you hear, which films rise, and what goes viral. The legacy extends even deeper into how we understand the human mind itself. Efforts to build intelligent machines have forced us to ask, what is thinking? What is consciousness? Where does creativity come from? As machines learned to replicate what we once thought uniquely human, speech, emotion, even humor, we were forced to re-examine our own definitions. And then there is the legacy of interdependence. We've entered an era where no major decision, economic, political, medical, environmental, is made without algorithmic input. AI has not replaced human judgment, but it has redefined what informed judgment means. Equally lasting is the caution AI has taught us. The perils of bias, privacy erosion, and unchecked automation are now part of the cultural conversation. Deepfakes, surveillance, algorithmic injustice. These are not future concerns, they are now, and they have demanded a new level of digital literacy, public awareness, and ethical responsibility. Perhaps most remarkably, AI's legacy is in what it has inspired. A generation of thinkers, creators, and citizens who now see intelligence as something that can be taught, shared, and remixed. Who see technology not as cold machinery, but as an evolving companion in the human story. AI has become more than a tool. It's a mirror, a magnifier, a partner, and a legacy still being written. So what lies ahead? If the last decade was defined by breakthroughs and adoption, the next may be shaped by integration, not just of systems, but of intelligence itself. We stand at the edge of something far more profound than faster processors or better apps. We are entering an era where machine cognition could blur entirely with human creativity, intention, and even emotion. Researchers are now building multimodal AI, systems that don't just read or hear, but see, speak, feel, and decide across sensory inputs. Imagine a model that watches a live video, hears a question, analyzes tone, detects movement, and responds with empathy. That's not science fiction. It's in development. Others are racing toward artificial general intelligence, AGI, a model with broad cognitive abilities across domains, capable of abstract reasoning, flexible learning, and perhaps even self-reflection. While timelines vary, most experts agree, we may see a credible form of AGI within this century. Some say decades, others less. Meanwhile, AI will embed deeper into governance, climate science, elder care, disaster prediction, education, and emotional companionship. In places lacking doctors, teachers, or infrastructure, AI may become the first responder, and sometimes the only one. But questions loom large. How do we ensure alignment between AI's actions and human values? How do we build transparency into black box systems? Can ethics scale as fast as innovation? There are risks ahead of inequality, dependency, manipulation. But there's also a staggering opportunity to build a civilization not just more automated, but more aware, more responsive, and more intelligent in every sense. So we leave you with this. What should intelligence serve? And who gets to decide? What will creativity mean when machines become our collaborators? And how much of our future will be written by us, and how much by the minds we've made? From ancient myths of thinking machines to real-world algorithms shaping how we live, work, and dream, the rise of artificial intelligence is more than a story of progress. It is a transformation of the human experience itself. We've traced its roots in logic and war rooms, witnessed its rebirth in code and silicon, and seen it evolve from silent helper to trusted advisor. Now it lives in our homes, our hospitals, our headlines, not as a visitor, but as part of the structure. What happens next is still unfolding. If this journey fascinated you, if it made you pause, wonder, or question the world we're building, then don't let the story end here. Like this video to show your support. Share it with someone who still thinks AI is just a trend. Comment your thoughts below. We want to hear them. And subscribe for more deep dives into the world shaping tomorrow.